Hi everybody, let's do 7th grade DD.7. Go to Learning, go to 7th grade, and go down to DD.7. Compound events, find the number of outcomes. This exercise is basically the same as 7th grade DD1, so let's review the counting principle. Over here, I'm going to look at the reference pages. Probability is on page 11, so I will scroll down to page 11. And here's probability. And over here this is really all we'll need for this exercise, the counting principle. What does that mean again? It means to find how many combinations there are, multiply the number of ways each thing can happen. For example, the number of different combinations of outcomes of flipping a coin, which has 2 sides, and rolling a number cube, which has 6 faces, is 2 times 6, which is equal to 12. Let's go ahead and do some IXL problems. You roll a die and flip a coin. How many outcomes are possible? This is actually exactly the example that I give right over here on the reference page, where you flip a coin and roll a die. The order doesn't matter. And I talked about this exact example in another video on 7th grade DD1, so I'm not going to go through all the outcomes here. Again, this would just be 6 times 2, which is 12. That's the exact example that we just read. Okay, what about this one? You spin the spinner and roll a die. How many outcomes are possible? Well, if we spin the spinner, it might land on X, it might land on Y, and it might land on W. And then we're going to roll the die, or the number cube, and we might get a 1, a 2, a 3, a 4, or a 5. So, for example, we might get a W here and a 3 here. Or we might get a Y here and a 6 here. Or we might get a Y here and a 2 here. So how many different combinations are there? Let's go ahead and write an organized list. We might get Y1. We might get Y2. Y3, Y4, Y5, or Y6, or we might get X1, or X2, X3, X4, X5, or X6, or we might get W1, or W2, W3, W4, W5, W6. So how many different combinations are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Is there a faster way that we could have figured that out? Yes, there is. We could just say there are 6 possibilities for the number cube, times 3 possibilities for the spinner, and 6 times 3, of course, is 18. Okay, and when you look at this matrix of values over here, it's pretty easy to see that if I wanted to count the number of elements in this matrix here, again, it would just be 1, 2, 3, 4, 5, 6, times 1, 2, 3. So again, 6 times 3 is 18. You flip a coin and spin the spinner. How many outcomes are possible? Let's go ahead and figure this one out with a tree diagram. Let's practice that. So we might get a heads and we might get a tails. After, for flipping the coin, might get a heads, might get a tails. After we flip the coin, after, let's say we got a heads, we might get heads and then 1. Or we might get, oh, wait a minute. Sorry, this is not 1, 2, this is D, E, F, G, H. My mistake. So we might get heads and then get D. Or we might get heads and then E, heads and then F, heads and then G, heads and then H. This H over here stands for heads. This H stands for the H on the spinner. But we might also flip the coin and get tails, and after we get the tails, we could get a D or an E or an F or a G or an H. So how many different outcomes are possible? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Is there a faster way we could have done that? Yes, there is. There were 2 outcomes for the coin flip. There were 5 outcomes for the spinner. 2 times 5 is 10. So there are 10 possible combinations. Okay, this one is just going to be 1, 2, 3, 4, 5, 6 times 1, 2. 6 times 2 is 12. Okay, these are all about the same. This one would be 3 times 2, which is 6. Now, don't get confused. Even though this spinner says 6 and 7, you're not going to be multiplying by 6. You're not going to be multiplying by 7. This 6 here is just a picture of a 6. Just like on the last spinner, we had a picture of a D and a picture of an E. Did we multiply by D? Did we multiply by E? Of course not. Those things are just pictures that somebody put on the spinner. The important thing is that there are 2 possible outcomes for this spinner. So for this example, we would do 3 times 2, not 3 times 6 or 3 times 7. The answer is 6 because 3 times 2 is 6. All right, I'm going to jump ahead to the next level. Well, once again here, don't get confused by these numbers. This 2, this 3, and this 4, these are just pictures, right? Like sometimes playing cards have pictures of a king or a queen on the front, or I forget which side for a card is the front and which side is the back. Yeah, I think the front. So on a playing card, they might have a king or a queen. Does that mean that you would multiply by king or multiply by queen? No, those are pictures. In this example, you would just count 1, 2, 3 times 1, 2, which again would be 6. Okay, let's move on to the next level here. All right, now how many different possible outcomes are there for if we pick a card and then we pick a marble? So we're going to close our eyes and randomly pick a card. We're going to keep our eyes closed and randomly pick a marble, and then we're going to spin the spinner. How many different outcomes are possible? Let's see if the counting principle works here. So there are how many outcomes for picking a card? 1, 2, 3, 4, 5, 6, 7. Times, how many outcomes are there for picking a marble? Well, we might get the pink marble, we might get the green marble. So that's 2 outcomes there. And how many outcomes are there for the spinner? Well, it might land on C and it might land on D. So there are 2 outcomes for the spinner as well. Now, 7 times 2 is 14. 14 times 2 is 28. So the counting principle tells us that there are 28 different combinations. Is that true? Let's work it out. If I randomly pick a card here, I might get a 1. And then if I pick a marble, I might get the pink marble. And then if I spin the spinner, I might get a C. But I might get 1 pink D. Or I might get 1 green C. Or I might get 1 green D. But I could also get 2 pink C, 2 pink D, 2 green C, 2 green D, I might get 3 3PC, 3PD, 3 green C, 3 green D, 4 PC, 4 pink D, 4 green C, 4 green D, 5 pink C, 5 pink D, 5 green C, 5 green D, 6 pink C, 6 pink D, 6 green C, 6 green D, 7 pink C, 7 pink D, 7 green C, 7 green D. I think that's every possible combination. How many combinations are those? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. Oh, okay, yes. So the counting principle still works if we have 3 different events. So we're picking a card, we're picking a marble, and then we're spinning a spinner. In fact, it works if we have any number of things that we're doing. Okay, this would be 2 times 6, which is 12, and 12 times 2, because a coin could land on heads or tails. That's 2 outcomes. 12 times 2 is 24. So we're just counting how many different ways each thing can happen, and then we're multiplying those numbers. This would be 2 times 2. Again, don't get confused with these numbers that you see on the spinner. There are 2 possibilities here. So 2 times 2 is 4, and 4 times 6 is 24. All right, let's jump ahead to the next level, see if there's anything different. Again, do not get confused by the numbers that you see on the cards. How many different cards are in this set? 1, 2, 3. How many cards are in this set? 1, 2. How many cards are in this set? 1, 2, 3. So that would be 3 times 2, which is 6, and 6 times 3 is 18. All right, I think everything else here is about the same. Have a great night.